All right, guys, let's go ahead and read lesson 2 of chapter 7, the inner planets. So let's go ahead and get ourselves set up first. So planets made of rock, go ahead and highlight that blue. Mercury, green. Venus, red. Earth, purple. And Mars, orange. Then we are at the end of our lesson, and we are at our 2 vocab words, greenhouse effect and terrestrial planet, okay? All right, so orange, purple, red, green, blue. All right, so let's get our notebooks, our outline notes set up the same way. Blue, green, red, purple, orange, and then we are finished at this point, okay? Because if we scroll a little bit further, then we see that we are at lesson 3, okay? All righty. The inner planets, Mercury, Venus, Earth, and Mars, are also called terrestrial planets. Terrestrial planets are the planets closest to the sun and are made of rock and metal and have solid outer layers. You could actually stand on them. Like Earth, the other inner planets are also made of rock and metallic materials and have a solid outer layer. So rock, have a solid outer layer. As shown below, Mercury, Venus, and Earth have a solid inner core and a liquid outer core. The core of Mars is liquid with no solid parts. However, the inner planets have different sizes, atmospheres, and surfaces. So we can see we have our core and inner core, liquid core, mantle, crust. All right. So now we are ready to do our notebook, outline notes. The inner planets are those closest to the sun. They are also called the terrestrial planets. The inner planets are made of rock and metallic materials. The outer layers of the inner planets are in the solid state. Okay? So stop this video if you need to get that filled in, all right? We are now ready to talk about Mercury. So Mercury is the smallest planet and the planet closest to the sun. Mercury has no moon and no atmosphere. The strength of a planet's gravity depends on its mass. Mercury's small mass creates weak gravity that cannot hold on to an atmosphere. With no atmosphere, there is no wind that move energy across the planet's surface. This results in temperatures as high as 450 degrees Celsius on the side of Mercury facing the sun and as cold as negative 170 degrees Celsius on the side facing away from the sun. Mercury's surface, impact craters, depressions formed by collisions with objects from space cover the surface of Mercury. We're familiar with that when we talked about the impact craters on our moon. There are smooth plains of solidified lava from long ago eruptions. There are also high cliffs that might have formed when the planet cooled quickly, causing the surface to wrinkle and crack. Without an atmosphere, Almost no erosion occurs on Mercury's surface, similar to why those craters are still on the moon, because it doesn't have an atmosphere, so there's no erosion. As a result, features that formed billions of years ago have changed very little. Mercury's structure. The structure of the inner planets are similar. Like all inner planets, Mercury has a core made of iron and nickel. The mantle of silicon and oxygen surround the core. The crust is a thin, rocky layer above the mantle. Mercury has a large core, possibly formed by a collision with a large object during the planet's formation. All right, so we are ready to do our outline notes for Mercury. So Mercury is the planet closest to the sun. Mercury has no gases close to its surface, which means it has no atmosphere. Because of its small mass, Mercury's gravity is not strong enough to hold gases to its surface. Because Mercury has no wind to move energy from place to place, the temperature on the side of Mercury facing the sun is always extremely high or hot. Mercury's surface is covered with impact craters, smooth plains, and high cliffs. Mercury has a core made of iron and nickel. Its mantle is made of oxygen and silicon. Okay, so make sure you have all of this filled in before you move forward. Mercury, we want to put off to the side here, has no moon. Okay. All right, time for Venus. So Venus is the second planet from the sun. It has no moon. It is about the same size as Earth. Venus rotates so slowly that its period of rotation is longer than its period of revolution. So its day is longer than its year. Unlike most planets, Venus rotates from east to west. All right, so this is pretty cool. Its day is longer than its year. So Venus's atmosphere. The atmosphere of Venus is about 97% carbon dioxide. Carbon dioxide is that, 1 carbon, 2 oxygen. Its atmospheric pressure is nearly 90 times greater than Earth's. Venus has almost no water, yet a thick layer of clouds cover the planet, and those clouds are made of acid. Venus is the hottest planet in the solar system. So you would think that Mercury would be being a little closer, but it's actually Venus. Its temperature averages 460 degrees Celsius. Remember, 100 degrees Celsius is boiling. The greenhouse effect causes the high temperature. So here's a vocab word. The greenhouse effect occurs when a planet's atmosphere traps solar energy and causes the surface temperature to increase. The carbon dioxide in Venus's atmosphere trap energy and heat up the planet. The planet would be 450 degrees Celsius cooler without that greenhouse effect. So Venus's structure and surface. Solidified lava covers more than 80% of Venus's surface. The lava possibly came from volcanic eruptions. All right, so we are ready to do our outline notes for Venus. So Venus is the second planet from the sun. Venus rotates more slowly than it revolves. So a day on Venus is longer than a year on Earth. Unlike most other planets, Venus rotates from east to west. Most of Venus's atmosphere is made up of carbon dioxide. Okay, so let's put CO2. It's actually 97%. Venus is covered by a thick layer of clouds. The clouds on Venus are made of acid. Okay, so stop this video if you need at this point, because I'm going to scroll up a little bit here. Venus is the hottest planet in the solar system. The high temperatures on Venus are caused by the greenhouse effect. The greenhouse effect increases surface temperature because the atmosphere traps solar energy. Most of the surface of Venus is covered by solidified lava. All right, so it looks like we are at Earth. So stop this video if you don't have this finished yet, pause it, and we are going to go on to Earth. We know a lot about Earth, right? Earth is the third planet from the sun. Unlike Mercury and Venus, it has a moon. Gases and a small amount of water vapor make up most of Earth's atmosphere. The gases and vapor produce a greenhouse effect that increases Earth's average surface temperature. The effect and Earth's distance from the sun warm Earth. As a result, large bodies of liquid water can exist on Earth. Earth's atmosphere also absorbs much of sun's radiation. Let's highlight that. This protects the surface below. Earth's protective atmosphere, liquid water, and moderate temperatures support a wide variety of life. Let's highlight that. Earth has a solid inner core surrounded by a liquid outer core. The outer core is surrounded by a mantle. The Earth's crust is above the mantle. The crust is broken into large plates that slide past, away from, or into each other. So this is all like the tectonic plates and the layers of Earth that you're going to study in depth when you are in 7th grade. It is mainly oxygen and silicon. Natural forces constantly destroy Earth's crust and create new crust. All right, so let's go to our outline notes. Okay, so forgot to write that this has no moon for Venus. And for Earth, we have one moon. Okay, the third planet from the sun is Earth. Earth's atmosphere is made up of water vapor, and a mixture of gases. It's going to be nitrogen and oxygen, and then trace gases. We'll learn a little bit more about that a little later. The atmosphere produces a greenhouse effect. That increases Earth's average surface temperature. Life is supported on Earth because of its atmosphere, large bodies of liquid water, and moderate temperature range. Earth has a solid inner core and a liquid outer core. The mantle surrounds the outer core. Earth's crust is broken into large sliding plates. Earth's crust is made mostly of oxygen and silicon. Let's go ahead and get that all filled out, and we are ready for Mars, our last section. Mars. Let's change the color. Mars is the fourth planet from the sun. It is about half the size of Earth. Unlike the other inner planets, Mars has no solid inner core. Its core is liquid. Mars has 2 moons. Space probes have visited Mars. However, they found no liquid water or life on the planet. The atmosphere of Mars is much less dense than that of Earth. It is about 95% carbon dioxide. The temperature range from about minus 125 degrees Celsius at the poles to about 20 degrees Celsius at the equator. Winds on Mars produce great dust storms. Mars's surface. Iron oxide in the soil gives Mars a reddish color. The Martian canyon, Valles Marineris, is as long as the United States. The Martian volcano, Olympus Mons, is the largest known mountain in the solar system. Let's go ahead and highlight that. Mars has polar ice caps made of frozen carbon dioxide and ice. Craters cover the southern hemisphere of Mars. The northern hemisphere is smoother and appears to be covered by lava flows. So there we have our vocab. There we have Mars, and let's wrap this up. Finish it up with Mars. Mars is the fourth planet from the sun. Mars has 2 small moons. So let's put that over here in our margin just to be consistent. Many probes have visited the surface of Mars. Most have looked for signs of liquid water, and life. Mars' atmosphere contains mostly carbon dioxide. Remember, that's CO2, and that is about 95% carbon dioxide. Mars's surface appears to be red because its soil contains iron oxide. Ice caps on Mars are made up of ice and frozen CO2, carbon dioxide. Features on Mars's surface include craters, lava flows, canyons, and the largest known mountain, volcano, in the solar system. All right, there's our line, because next time we will start the outer planets. Okay, so make sure you have this all filled in and reach out if you need anything. Thank you. See you soon.